Simplify rational expressions. So now what we're going to be doing with this, we're going to be talking about how to simplify these expressions that have a variable in the numerator and or denominator. So the thing about it is that it is very similar in some cases to how you simplify fractions. In other cases, it's a little bit more complicated. So let's look and start with the easy, and then we'll move on from there. Just to remind you, a rational expression is an expression that can be written as the ratio of two polynomials. Okay, so a rational expression would be like this: x plus 3 over x minus 2. Okay, that is a rational expression. And one of the key things to understand about rational expressions is that you can never have a denominator that is equal to 0. So in this case right here, x cannot equal 2. That's as simple as you can get that expression, but x cannot equal 2. And that's a really important thing to understand, because if x equals 2, then the denominator is 0 and it won't work anymore. So that's what's called an excluded value. So let's look here. First of all, if you find excluded values, what you're doing is you're trying to actually solve for the denominator as if it's equal to 0. So negative 2x, if negative 2x is equal to 0, if you divide both sides by negative 2, you get x is equal to 0. So the only excluded value in this case is going to be x is equal to 0. And that's all we're doing right now. We're just finding excluded values. In this case here, all we care about is the denominator again. And we're just going to have this. 3x minus 9 is equal to 0. Divide both sides by 3, or excuse me, bounce the 9 over to the other side, and you end up with 3x is equal to 9. Divide both sides by 3, you get x is equal to 3. So the only value you cannot have is when x is equal to 3. Now this one here is a little bit more complicated, because what happens is you can factor this denominator. When you factor this denominator, you end up with x minus 3 times x plus 5. And if either of the two of those are 0, then the denominator will be 0. So in this case here, the two excluded values are x is equal to 3, because then that first part would be equal to 0. And the second excluded value is x is equal to negative 5. And that won't work for that. Because either way, if you plug it into this equation for either of those two values, if x is equal to 3, then that's 9 plus 6 minus 15. That's 0. And if you plug in negative 5, then you end up with 25 minus 10 minus 15, which is equal to 0. So either of those two will not work. So that's the important thing to understand. Now sometimes it'll look like you have excluded values, but you won't actually have excluded values because you won't come up with real numbers. If you remember when we talked before about using the quadratic formula, we used this thing called the discriminant, which was this right here, b squared minus 4ac. And that determined whether we had two values, one value, or no solutions. Because remember, it's negative b plus or minus the square root of b squared minus 4ac. That's all over 2a. And the negative b over 2a, that determined where the axis of symmetry was for the parabola. And then the discriminant part, this piece here, that allowed us to mirror the parabola. But if you have the negative b minus 4ac, if that's equal to a negative number, you can't do it. In this case here, what's happening is when we do that, we end up with 2 squared for the b value, so that's 4, minus 4 times 5 times 7. That's less than 0, so there's no real roots, so there's no excluded values. Now that's a little bit more complicated, but let's look and see. So it says here, find the excluded values, if any, of the expression. So again, all I care about is the denominator. So it's just going to be 5x is equal to 15. So x cannot equal 3 is the only thing. I know I said x is equal to 3, but x cannot equal 3 because I'm solving for the thing that will work. So now I'm going to try it with here. This is just, you should recognize that this is a perfect square. So x cannot equal, and that's just for the denominator again, for the x squared minus 16. X cannot equal 4 or negative 4. Again, you can try all these out into there, and you should test them all out. So here, when I plug that back in there, it'll give me 15 minus 15. When I plug either of these two back in there, it'll end up with 16 minus 16. This one here, when I do that, I'm going to check and see if there's any values that work. So let's try the do the discriminant. B squared minus 4ac. So b squared is going to be 25 minus 4 times 2 times 6. Okay, and that is going to be 25 minus 48. And that's going to be equal to a negative number. That's going to be actually equal to negative 23. So that means I have no real roots for that. For this one here, I end up with x squared plus 4x minus 12. And there I'm going to try and solve that by coming up with actual multiplication problem. Let's see if I can do that. Oh yeah, that one's actually pretty easy. It's x plus 2 and x minus 6. Actually, it's the other way around. No, it isn't. Yeah, actually, it is the other way. Plus this and then minus 2. Because that will give me the positive 4x when I FOIL it. So the only two values are x is not equal to, excluded values are 2 and negative 6. So sometimes we can go ahead and simplify things by just pulling out the things that work and having common factors. Like in this problem here, 2 and m are both things that are common factors on the top and the bottom. So I can just take the 2 and the m out. And when I do, I divide 2m into this and this, I end up with 1 on the top. When I divide 2m into 8m and then times that whole thing times m minus 1, what I ended up with is I ended up with 1 over 4 times m minus 1. Now, really important, I've got to remember both the excluded values because I got to do the original equation, and the original equation has 0 as an excluded value. The second equation, that isn't as obvious, or the final equation, when I simplify it, isn't as obvious, but and then 1 is the other one. So here, same sort of idea. I'm going to figure out what is common to everything. And really it's just, well, what's common to 7, 14, and 14? Well, the number 7 is. And then what's common to q squared, q, and q cubed? Well, q is common to all this. So I'm going to divide everything by 7q. And one way of doing that is by writing it out the way that it has it written out here. That sometimes is more helpful. By pulling the 7q out, because then that will cancel out. And then you're left with this here. And the only excluded value is going to be 10. So now, for these here, again, we're going to have to figure out the excluded values, and also we're going to figure out how to simplify. And the way that this works is I'm going to factor both of these different expressions here. So when I factor these expressions, what I end up with on the top, x plus 7 times x minus 3. And then on the bottom, I end up with x minus 2 times x minus 3. And if you notice, there's a common thing there. Common thing is here and here. Okay. Really important, though. I've got to remember that 3 is an excluded factor, because what I'm going to do is I'm not going to cancel them out. That's what's happening here. When I cancel them out, I'm just left with x plus 7 over x minus 2. And so the only two excluded values are 2 and 3. and that is how it works. So let's look here. So simplifying expressions, what I do here is, what are the things that I can divide by? Well, let's see. And yes, I just made it bigger. So what I need to do is, now looking at this problem here, what goes in both 3x cubed and 15x to the fifth? Well, 3 goes into both 15 and 3, and x cubed goes into both of them as well. So this is just, when I divide it out, I'm going to end up with 1 over 5x squared. So that's how it's going to look, and my excluded value is just going to be x is not equal to 0. For this one here, I'm going to figure out, okay, well, what are the common factors? Are there x's everywhere? No, so I don't have to worry about x's. But what goes into both 28, 7, and 21? 7 goes into all of them. So I'm just going to divide everything in there by that. So it's going to be 4x. Now I have to divide both here and here by 7, because those are two different parts of the expression. So this is just going to be x minus 3. And the excluded value is going to be equal to 3. This one here, the excluded value is going to be negative 3. And what am I going to divide by? I can't divide by anything, because there's nothing that I can divide by that's common in all of them. For here, what am I going to divide by? I'm going to pull out 5 on the top. When I do that, I end up with x plus 2. Then when I pull out 3x on the bottom, I end up with this x plus 2. Okay, so x cannot equal 2, and it cannot equal 0, because then the numerator would be 0. But then I can cancel these out, and I end up with 5 over 3x. Last page on this, so let's look here and see. What I'm going to try and factor these two, and I'll factor them out, and then I'll show you what I'm going to do with them. Okay, I just factored those two out. Factoring should be something you feel pretty comfortable with, so I'm not going to spend time discussing that. But what are the two excluded values? I like to do that first just to make sure. X is not going to be equal to 9, and it's not going to be equal to negative 7, because that would make the denominator 0. And now I'm going to cross off the things that match. I'm left with the expression x plus 6 over x minus 9. Now I'm going to do the same on the bottom here. Okay, the interesting thing in this case here is the top is going to be 2x plus 5, because that's a perfect square one. And then what ends up happening is when you go ahead and FOIL it out, you're going to end up with that value there. And on the bottom, that's the difference thing where we go ahead and we have the plus 5 and the minus 5, and that cancels out the middle term. So here, one way of thinking about it is, if I wanted to, I could rewrite this as this, if it makes it easier to understand. Because that's just what 2x squared, or 2x plus 5 squared is. And then it's easy to see that I can cancel out both these. But before I do that, let's go ahead and figure out the values that I can't have. X is not going to be equal to negative 5 over 2. Because when I solve for that, I end up with negative 5 over 2. Or 5 over 2 for the second one there. So now I can cancel this out with this. Now I'm left with just 2x plus 5 over 2x minus 5. And we're done.